you guys are probably familiar with this sort of stuff. What we're trying to do is, improve our design efficiency. In other words, reduce costs, but still produce the same product, maybe produce the product cheaper, quicker time to market, not having to waste money on doing physical prototypes, but being able to do them virtually and maybe doing a single physical prototype at the end. And hopefully that then, if it should, then reduce our reliability if we're producing a large number of components. Okay. So this is how it helps an engineer, a deeper understanding, validating your design, which of course you need to do quickly and early in the design process. Evaluate the design flaws or any potential design flaws, and if required, optimize designs. And these days it's optimization is something that can be done relatively quickly and easily, providing you've got the technology to do it, and you can further reduce costs. Okay, and really, I guess importantly, the main thing I would say is we're trying to reduce a lengthy design cycle. We're trying to cut that down, and as part of that, cut down physical prototypes and things like that. All right, so let's look at topology optimization. So there's a few different ways this is referred to within Creo. It's called generative design, topology optimization, GTO, specifically within Creo. It uses artificial intelligence and also simulation, so FEA, to help generate the optimal design. Okay, so we have done webinars and things like that in the past on this to explain it. However, imagine, like, this is a common example that we do use, but imagine that we know that, okay, we're designing something in this sort of blue region here. That's where it needs to interface with another component. Also down here as well, where we've got blue, it needs to interface with some bolts or something, or a pin. Okay. We also know that in red, there's something else that needs to be there, like in that's going to occupy that space. So what we do there is we say that becomes then excluded, like we can't create our geometry for it. And as part of this process, we also do effectively things that you do in finite element analysis, and that is you would create loads and constraints, and of course material properties. So, and we initiate that. So this process basically goes away and it solves an FEA type problem. And then if you're familiar with how that works, there's effectively a mesh, and it will just effectively remove areas of low stress and then rerun it, and then run it and remesh, and so on and so forth. So if we were to do this on screen and start with this analysis and look what happened, the graphics would update in real time. And as you can see here, if we move left to right, sort of the types of behavior that we get. And then when the analysis finishes, it changes color and tells us that's the final product. We'll talk a little bit more about the shapes and so forth you can get out of that, but obviously this is a fairly arbitrary type shape, but it certainly just shows you that you can set up loads and constraints and have the system work out a design for you that's potentially going to minimize your mass or things like that. Okay. All right, so this is something in Creo, this topology optimization, which runs locally on your own machine. So you just set it up, you set it away to run. It's like running an FEA analysis. It'll take some time to work that out, and then it'll come back with a result. Now, there is also within the Creo suite a generative design extension, and what that allows you to do is to set up some variations of your design. Maybe you can change material properties, maybe you change the load scenarios, maybe you change the manufacturing constraints that you're going to use to create this model. And effectively then what you do is you send that to the cloud, okay, and it uses technology in the cloud or processing power in the cloud to come back to you with a list of suitable designs that satisfy whatever criteria you might have. You start out maybe with a graph that says, okay, this is what the maximum stress is. In this case, this is optimization, but we can start to find something that has the stress levels where we want it to be. And then we can start to interrogate that. And if you see here, we have a number of different designs that that have come out of this. Now, if we look at these closely, we see some that, like for example, this one, that it looks like it's just an extruded profile from, let's say, bottom to top or top to bottom, which controls how that's going to be created. So that could be easily you know, created with an extrusion type operation and then a trim off operation, or it could be machined, okay? So here then we've got some other options, as you can see, and some of these are going to be something like this here is something, the only way you're going to be able to create that probably is something like 3D printing. So it comes down to your material choice and things like that. Okay. Also, as part of this, you know, one of the things you can do is separate how, like, if you want big holes or small holes and things like that, depending on what your application might be. But once you have that, then you can then bring that model from the cloud back down to your local machine, and then work on that. Okay, and then use that locally. So the benefit of really doing this is because you can generate, as you can see, you can generate lots of different designs. You send it off to the cloud, you come back, however long that might take, and then you can just filter and compare, whereas on your local machine, really you've got one at a time, okay? All right, so moving on to now, this is no longer generative design, it's Creo Simulation Live. This is technology that ANSYS developed number of years ago now. They call it Discovery Live, and it's embedded inside Creo, and it allows us to provide real-time feedback. And when I say real-time, you'll see what I mean in a moment when I talk about when I show you the software, how quickly we get results. Okay. Now, there's a list of different capabilities there, but we've got structural analysis, we've got modal, we have thermal, and also fluid flow. Okay, and there's different license options depending on whether you need the fluid flow simulation or not. So that's the simulation live. So that's done with your GPU. It's done on you know, effectively in real time. You'll see that. All right, ANSYS simulation, or also I'd say Creo Simulate as well. That's high fidelity results. Okay, so that's a traditional FEA approach. We mesh it, we can have some control over the mesh, we can have some more real world impacts with respect to like how models are contacting each other, if we're using, you know, non-linear materials, and or large deformation and things like that. So if we're starting to, you know, get right into it and want really high fidelity results. So if I was to compare the, because these are two different things, okay, if I was to compare the two, this is more for qualitative type results, the simulation live. So it's like a better or worse scenario. So if you're the engineer, you can say, all right, I want to just change this. I want to change this dimension to this. I want to make this feature bigger or smaller. And then immediately get some feedback and think, okay, well, that's that's worse than what I wanted, so I'm going to put it back to where it was. Okay, and then maybe change something else. Which it's really good at giving you those sort of results. But as far as giving you high fidelity type results, perhaps something you could create a report out of and you know, and perhaps send to an analyst, third party, who might come up with the similar results. It's not really used for that. To be honest, it's more better or worse type scenario. It can, in some cases, give you very accurate results, but in others, depending on your models, if it's very, very complex, then no, it won't. And then this one here is for the quantitative. So if you want accurate results, then you would use Answer Simulation or Creo Simulate. Okay. All right, so if we look at this, Creo Simulation Design, simulation, basically this is just talking about, again, this is showing the same slides. I think we might just jump over that so we can have time for the demo. But topology optimization, this is just showing you the ability for you to like set different parameters within there that control what geometry gets created. So in the first case, you're allowed to limit the volume to 85%. If you limit it to 55%, it takes those outer bits out of there. So there's a lot of different parameters that you can set up inside topology optimization. Okay, so these are some other things that are available. There's design exploration extension. Effectively, this is allowing to like change have different scenarios you might like to run. So you can have within the same file, within the same part file, different stages of it, which you can analyze, and you can just swap between them and the analysts, and it gives you some sort of way you can record what different changes you might have made. All right, Simulation Live, we talked about behavioral modeling. It's multifaceted, this, and it can do lots of different things, but probably the where it has its most power is in the ability to do things like geometry optimizations, and things like volume or something like a balancing of a crankshaft or something like that. Okay. Topology of optimization we've talked about, and so have we talked about Answer Simulation.